Hello, ECE 473 class. Today we're going to be demoing our autonomous car. It's set up so that we have 4 turning wheels on motors, and when we put something in front of the sensor, the wheels they'll default to going forward. When we put something in front of the sensor, the wheels will go backward. Let me show you. And we move it away, and there's a bit of delay, but it'll go back to being forward. So the whole idea is that this is a reactive thing, and you have inputs coming in from the sensor, um, connecting to the TIVA board. And the TIVA board connects to all of these motors and tells them when to move forward or backward. All right, so to elaborate a little bit further on how the autonomous car actually works is that I made 2 flowcharts demonstrating how all the power is connected, how the whole car is powered, and how all the data is connected, so how the car knows what to do. So for the power, we have 2 9-volt batteries powering 2 motor drivers that are responsible for 2 sets of wheels each. So there's one motor driver that's responsible for the front wheels, and there's one motor driver that's responsible for the back wheels. On the motor driver for the front wheels, and it's like multiplexed. So there's 4 pins on each motor driver, and let's say for example, pin number 1 would control wheel 1 to rotate clockwise. Pin number 2 would make wheel 1 go counterclockwise. And then pin number 3 would make wheel 2 go clockwise. Pin number 4 would make wheel 2 go counterclockwise. So that's how you can actually control them. But that's how the wheels are powered, indirectly using 2 9-volt batteries, 1 for each motor driver. We just had the laptop directly connected to the TIVA board, and the TIVA board powered the sensor. During that little demo, we wanted to keep the car on a little pedestal because just to show the wheels turning, because if we were to actually let the car run, it would unplug from the laptop, and the power would be disconnected. So we couldn't actually. We could run it and like carry the laptop with us, but we figured it'd be easier to demo on that pedestal. Anyway, so here's how the data works. So it's a simple input-output. It uses GPIO. So the sensor is connected to port A. The reason why it's both an input and an output technically is because the sensor works by sending a output signal, and then it checks and sees like that output signal, like it's gonna bounce, and then it has an input recording how long it took for that output signal to be caught. So as far as like our project is concerned, it's really being used as an input, but technically there's 2 pins, one as an output, one as an input. And I'll show some code that'll help explain this a little bit better. But essentially this is an input being connected to port A, and then we have 8 control pins. Like I said, there were 4 pins for each motor driver, and it's kind of like multiplex. 2 pins are responsible for making a wheel go clockwise and counterclockwise. Then we have to do that for 2 wheels. So it uses the entirety of port B, pins 0 through 7 from the TIVA board, and that's how we can control it. We have a bunch of functions set up in terms of port A that output to port B. So let me show some code now. So sorry about that. So I have it open in Notepad++ because I didn't want to install UVision on this computer, because this actually isn't the computer I demoed on. But anyway, here's some code, and let me elaborate. So we have some GPIO initialization. This is for port A for the sensor. So the sensor has 2 pins, trigger and echo. Trigger is the input pin, echo is the output pin that I described earlier. So we're just setting up the appropriate inputs and outputs. We don't have to worry about this. So down here, this is a function being called for the sensor. So the way I have this set up is that It takes 10 microseconds for the output signal to be read, or for the output signal to be sent. So what happens is we send the output signal trigger and delay for 10 microseconds, and then we check and see if our input signal echo changed. So if it's equal to 0, then we just set these wheels in GPIO port B to AA. That makes the wheels go forward. I'll explain this farther down. And then here, if it detects something, what it'll do is it'll increment a counter and delay for a microsecond, and then it'll keep doing that until the counter hits its max value of 7,500. And and that calculates distance. So that will actually tell you how far away an object is, but we weren't interested in that. We just wanted the car to react. So basically what will happen is right here, we calculate distance, and if distance, I believe this is 1 foot. So if the distance is 1 foot or less, what it'll do is it'll actually change the wheels. It'll make the wheels go in reverse. So I don't know why the code's like this. It should actually be like this. I'll explain what this means. So basically, here's the controls for the actual wheel. This is mostly debugging information here. Not much of this actually got used. The key thing, I don't know why some stuff is commented out. Basically, what's going on is so we do some port B initializations. We call these functions to support A initializations that initialize the sensor. And then this is all commented out. We call this write distance function, which is constantly scanning the sensor and reacting. So this is some information to show you how each of the wheels work. So we can control each wheel at a time, however we want. So these comments tell you what each bit in port B will do to each wheel. So for example, pin number 0 of port B will make the front right wheel go in reverse. So to simplify things, if we set port B equal to AA, that'll make both wheels turn forward. If we set port B equal to 5,5, that'll make both wheels go in reverse. So that's what's happening in here. We're making it default to go forward, and then if this counter hits the value that it needs to hit here in order to make distance, in order to keep distance less than 1, what will happen is the wheels will go in reverse, as if it's seeing some object in front of it, and it'll turn around. So I believe that is all the explanation I need to give here. So that's it. That's our project, the autonomous car using GPIO. Thank you. Goodbye.